Okay, so let's talk about the graph of a function. First thing we're going to talk about is symmetry. So, symmetrical with respect to. Now you know what symmetry means. One side looks exactly like the other, right? So we're going to speak about that graphically by looking at a graph. And there's three symmetries we're going to look at. We're going to look at x-axis symmetry, y-axis symmetry, and then origin symmetry. So let's look at x-axis symmetry first. It says for every point on the graph, okay, so here's a point x, y, and let me identify that a little bit better. So for every point x, y on the graph, now they want to know what other point would be on the graph if it has x-axis symmetry. Now let's think about it. If the x-axis is the mirror, that's how I want you to think of symmetry. I want you to think of it like a mirror. If the x-axis is the mirror, and this point looks at itself in the mirror, which quadrant will it end up in? Good. I hope you said it ends up here in quadrant 4, because it will. So the question is, what does this point look like in quadrant 4? The x is still positive, that's true. And the y? Good, the y is negative. So for every point xy on the graph, the point x negative y is also on the graph. Good? Okay, so let's look at the next one for y-axis symmetry. For every point xy on the graph, now the y-axis is acting like the mirror. So when this point looks at itself in the mirror, where will its reflection be, so to speak? Yeah, it ends up over here in quadrant 2, doesn't it? So in quadrant 2, what does this point look like? Yeah, it's a negative x and a positive y, isn't it? Okay, so for every point xy on the graph, the point negative x, y is also on the graph. Excellent. Let's look at the last symmetry, origin. So for every point xy on the graph, so now here's the point xy on the graph. The origin, remember, is where the x and the y-axis intersect, correct? So when this point looks at just this is now the mirror. Where will its reflection end up? Good. I think I heard some of you say it. When this point looks at itself in this mirror, its reflection is over here in quadrant 3. So when it's in quadrant 3, what does that point look like? Good. It looks like negative x and a negative y. So for every point xy on the graph, the point negative x and negative y is also on the graph. So when they ask you about these symmetries, x-axis symmetry or y-axis symmetry or origin symmetry, you need to think of these axes and even this one point as a mirror. And when anybody else looks in that mirror, where will its reflection be? Got it? Okay, so we're going to talk about symmetry algebraically, so hang in there. Okay, so let's look at some algebraic tests for symmetry. Let's start with the x-axis. Do you remember, and maybe I should draw this, do you remember that when we had the point xy and the x-axis was the mirror, do you remember that that point ended up here in quadrant 4 and it was still a positive x but now a negative y, right? Okay, so here's the algebraic test then for symmetry. We are going to replace y with negative y, right? Because that's what the symmetry, the x stayed the same, it was the y that changed. So when you replace y with negative y, if an equivalent equation results, then the graph is symmetrical. By the way, here's my shorthand. With respect to. WRT is my shorthand for with respect to the x-axis. So when you replace y with negative y, and the equation that results is equivalent to the original equation, then the actual graph of that equation will be symmetrical with respect to the x-axis. Good? Okay, let's look at y-axis symmetry. Remember, if the y-axis is the mirror, then the reflection was over here, wasn't it? And it became a negative x and a positive y, didn't it? Okay, so guess what? Guess how we're going to start this one? Yeah, we're going to replace x with negative x because the y's stayed the same when there was y-axis symmetry. The x's are the ones that changed. With me? So replace x with negative x if an equivalent equation results, then the graph is symmetrical with respect to the y-axis. Good? Okay, one more symmetry, origin. So remember, this point is looking at itself in the origin, and it ended over here in quadrant 3. And when it ended in quadrant 3, both x and y changed sign, didn't they? So when we're testing algebraically, what do you think you're going to replace? Yep, I heard you say it. So we replace x with negative x and y with negative y. Do you think the rest of this definition is going to change? Nope. If an equivalent equation results, then the graph is symmetrical with respect to the origin. Cool? So when we're testing algebraically, we're taking our clue, we're taking our lead from the graphic end of the world. When the point looks at itself in the x-axis mirror, the x stays the same, the y changes. So we're replacing the y. When this point looks at itself at the y-axis like the mirror, the y's are staying the same, the x's are changing, so we're replacing the x's. And when this point looks at itself in the origin mirror, both x and y change, so algebraically, both x and y are going to get replaced. So hang in there, got a couple of algebraic examples. Okay, so let's look at a problem. The directions say symmetrical with respect to, so they're asking us if this particular equation has any symmetry whatsoever. It could have one, it could have two, it could have three symmetries. I don't know until I test. So, the first one I'm going to test for is x-axis symmetry. Why? Because that's the first definition we wrote. So, no other reason. Now remember, x-axis symmetry meant that the x's stayed the same. It was the y's that did the changing. So, we are going to replace y with negative y. So, let's see what this looks like when we do that. So, instead of the y here, I'm going to put a negative y in its place and then square it. And equals x plus 4. Now, can I simplify? Can I simplify a negative y being squared? Yeah, it's going to be a positive y, isn't it? Squared. I know the negative will turn positive, but since I still don't know what y is, the square has to stay. So, equals x plus 4. So the question is this equation equivalent to the original? Yes, it is. So looks like in this case we have x-axis symmetry. Yay! Okay, let's look at y-axis symmetry now. Remember, for y-axis symmetry, the y's stayed the same. It was the x's that were changing. So we're replacing x with negative x. So let's look. Instead of it being x plus 4, it's going to be a negative x plus 4. When I simplify, there's not really a whole lot I can do to simplify it other than remove the parentheses. And is this equation equivalent to the original? No, it's not. So it does not have y-axis symmetry. With me? Okay, origin symmetry is last. Do you remember what happened with origin symmetry? Yeah, both got replaced, right? So, might help if I spelled replaced correctly, wouldn't it? So we are going to replace x with negative x and y with negative y. So instead of y, I have negative y being squared equal to a negative x plus 4. Simplification, this becomes a positive y squared. This is still a negative x plus 4. Is this equation equivalent to the original? Nope. So do we have any origin symmetry? Nope. In this case, this equation has one symmetry, x-axis symmetry. So when you actually graph this equation, this graph is going to have symmetry with respect to the x-axis. The top of the x-axis and the graph below the x-axis, they're going to be symmetrical to each other. Cool? Hang in there. Okay, so let's take a look at the second problem. The directions are still the same. They would like to know if there is any symmetry for this particular equation. So, let's test x-axis symmetry first. Remember, x-axis symmetry says the x's are staying the same. It was the y's that were changing, right? Okay, so we are going to replace y with negative y. So let's see what this looks like. So instead of it being a y there, I'm going to have a negative y equals the 5th root of x. Can I simplify it all? No. Is this equation equivalent to that one? Nope. So I do not have any x-axis symmetry in this particular case. Cool? Okay, let's look at y-axis symmetry. And again, remember, y-axis symmetry means the y's stayed the same. It was the x's that were doing the changing. So we're going to replace x with negative x. So it's going to be y equals the 5th root of a negative x. Now, the question is, can we do any simplifying? Some of you are like, I don't know. Some of you are thinking no. Some of you are thinking yes. So I've got like all three of your answers roaming around. So here's how I'm going to get you to figure this out. And I'm going to sidetrack you a second. If I asked you to find me the cubed root of a negative 8, what would you tell me the answer is? Good. You would say the answer is negative 2. If I asked for the cubed root of a negative 125, what would your answer be? Good. A negative 5. Okay, what happens if I asked you for the cubed root of a negative 7? You may not know the cubed root of 7, but you know the answer is going to be negative, don't you? So that means you'd have a negative that would come out, and still the cubed root of 7, because you don't know it without a calculator. Good? Okay, so this may not be a cubed root, but it is a 5th root. It is an odd root, and this odd root acts just like this odd root acts, which means when I take the odd root of a negative number, your answer is going to be good. Your answer is going to be negative, which means in this case, you have a negative that's going to come outside of this 5th root. So I have y equals a negative fifth root of x. Can I simplify it any further? Nope. Is this equation equivalent to the original one? No, it's not. So I don't even have any y-axis symmetry in this case. Are you with me? Okay, last symmetry is origin. And remember, origin symmetry, both x and y changed, didn't they? So replace x with negative x and y with negative y. So instead of y, it's going to be negative y equaling the fifth root of a negative x. Agreed? Okay, now I know that when I take the fifth root of a negative number, I'm going to get you're going to get a negative answer, aren't you? So this is the negative fifth root of x, isn't it? Now my question is, can you simplify this last line? Some of you may see that you can, and some of you are like, I'm not sure. So let me sidetrack you again. Come over here to this little end of the world. If you had negative x equaled negative 3, what would you tell me for the next line? Yeah, you would tell me x equaled 3, wouldn't you? Right? If you had, negative x equaled negative 2/5, you would say x equaled a positive 2/5, wouldn't you? So over here, yeah, you would have y equaling a positive fifth root of x, which means this equation is now equivalent to this one, which means in this particular case, I do have origin symmetry. No x-axis, no y-axis, just origin symmetry. Cool? Okay, so hang in there. We're going to look at some of these symmetries graphically. Okay, so let's look at some applications. I promised you we were going to look at some graphs, so here we go. Let's take a look at this particular graph. They're asking me to answer some questions. Now, first off, look at the graph itself. The graph itself gives me a bunch of points on it. So clearly I have a bunch of x's and a bunch of y's. Agreed? And now I need to answer a few questions. So let's look at the first question. They would like you to find f of negative 21. Well, we need to remember what f of negative 21 means. This negative 21 is in the place of the x, isn't it? Which means in this case, x equals negative 21, and they want to find y. So, look for your x's being negative 21. I see an x value here of negative 21. What's the y that goes with it? Good, negative 6. Were there any other x values of negative 21? Nope, I don't see any. So that would be my answer in this case, is negative 6. Cool? Okay, so let's look at f of negative 9. Again, the negative 9 took the place of x, didn't it? Which means in this case, x equals negative 9. So that means find y, doesn't it? Okay, so let's look where my x's are negative 9. I see one up here where x is negative 9. That means the y is a positive 9. Do you see any other place where x is negative 9? Nope, neither do I. So that would be the answer there, that y would equal a positive 9. Good? Are you with me? Okay, let's get a few more problems down here. And I am going to move pages. We're going to find f of 12 and f of 18. Okay, so go back to the previous. So I want f of 12. So that means, good, x is 12. So here's x being 12, and what's your y value? 0. So that answer would be 0, wouldn't it? Good. And the other one was f of 18. I see 18 here. And so it looks like that's a y value of 6. Agreed? Good. So far, so good. Are you with me? Okay, let me get another one for us. I would like us to find, f of x being equal to 6. So now, the question is this. What did they give me and what am I trying to find? In this particular case, they're asking us to find x when y is equal to 6. Got it? Okay. By the way, I'll put B, C, this is D. So, I'm trying to find x when y equals 6 because the x is now the unknown. It is the blank, so to speak. So, y equaling 6. Where are my y's equaling 6? Here's a place where y equals 6. Any other place where y equals 6? Oh, I see another place where y is equal to 6. Let's see. Any other place where y is equal to 6? I don't see any other place. That looks like it might just be it. So in this case, I have two answers for x, don't I? I have x being a negative 6 and a positive 18. Agreed? Good. Okay, got another one for you. What about f of x being greater than 0? F of x being greater than 0. So, okay, take a look. F of x being greater than 0. That means x needs to be what kind of number? Yeah, x needs to be a positive number, doesn't it? Right? Okay, so if x, or I should say they're looking for positive, they're looking for where the graph is positive. When they said f of x greater than 0, they're looking for where your graph is positive. So, where is my graph positive? Yeah, I see my graph positive here because it's above the x-axis, and I also see the graph being positive here because it's above the x-axis. Now, answer me this before we go any further. What variable are they asking us to find? Yes, they're asking us to find x because the x is blank, so to speak. They literally have x there. They don't have a number. They have x. So, what are my x's that are keeping this part of the graph above 0? Yes, let me erase this. Some of you can see it, some of you can't. It looks like my x's are starting at negative 18 and they're ending at, what is that? Negative 3. Okay, here's the point right here. If you're like, how do you know it's negative 3? There's the point. So they're starting at negative 18 and they're ending at negative 3, aren't they? So we're going from a negative 18 to a 3. Pardon me, negative 3. Now, did it say anything about being equal to 0? No. So I'm not going to put the equal to's. Okay. But we had a second place where x was, or this graph was positive. So let me erase this circle so we can see it better. It looks like it starts here and ends here, doesn't it? That's keeping this above the x-axis. It's keeping it positive. So it looks like we start at 12. Good. And we end at 18. And again, it's not equal to because it didn't say equal to there. Does that make sense? Loving it. There are oodles of questions I could ask you about this particular graph. These are just a few of them. With me? Okay. So let's keep moving. They've given me a graph here. And first thing they're asking us to do is determine if this graph is that of a function. Now remember what we said, the definition of a function is for every input there's one output, right? So here's an input. Where's the output that goes with it according to the graph? Yeah, the output's up here, isn't it? But is that the only y value that goes with it? Nope, I got a second one down here, don't I? This particular x has this y and this y. Good? Okay, let me try that again. This particular x has this y value and this y value. Is that going to be a function? No, it's not. Not a function. Good. Second thing they would like is the domain and the range. So, the domain and the range. Okay, so since we're looking at a graph, the domain deals with the x's, doesn't it? And x's go which direction? Good, left and right. So, when I look at this graph, I'm noticing that even though it doesn't have arrows here, there's no solid dots, which means the graph keeps going. And the question is, does the graph go straight up or does the graph go up and out? Good, you're right. It goes up and out. And what about this end of the graph? Does it go straight up or does it go up and out? Yeah, it keeps going up and out. And the same down here. It keeps going down and out and down and out. So the question is, over on this end of the world, what x values will we eventually reach when it keeps going out? Good, negative infinity. How about at this end of the world, what x values will we eventually reach? Good, positive infinity. So in this case, your domain is a negative infinity to a positive infinity. Cool? Okay, now it also wants the range. So, remember, the graph keeps going up and out and down and out. So, range refers to the y's because the y's are the outputs, right? So, this graph keeps going down, which means it starts at negative infinity down here, doesn't it? Okay, so where does it end? Yeah, if I look and I keep coming up and I keep coming up, the graph stops here, doesn't it? Okay, so you're like, well, what number is that? Well, what I'm noticing is these tick marks are in increments of 2s. 2, 4, 6, 8, 10, 12, same here. And this line being right between the negative 4 and the negative 6 tells me this is a, yep, negative 5. So it looks like my range is starting at negative infinity and going to negative 5. But there's a second part of the graph, and that starts here, doesn't it? Yep, that starts at positive 5 and goes up to infinity, doesn't it? Okay, so we know we put parentheses around our infinities. What are we going to put around that negative 5 and positive 5? Yes, brackets. And some of you are like, why brackets? Because this is a solid line passing through the 5 and the negative 5. And since it's solid, it's getting a bracket. Now, what do I put to keep these two interval notations or these two intervals together? Yep, that U. Remember, this U means the word or. So my y's are here in this first interval, or they're in that second interval. Good? Okay. Let's look at the next question, part B. Part B would like any intercepts. Well, when they say intercepts, they weren't very specific, were they? They didn't say x-intercepts and they didn't say y-intercepts, did they? Which means they want them both. They want any x-intercepts and they want any y-intercepts. So be aware of that. Okay, so let's go back to the graph and see what we can find in terms of intercepts. All right, any x-intercepts? Does this graph cross the x-axis at all? Nope, I don't see it crossing the x-axis either. Is this graph crossing the y-axis at all? Yes, I definitely see it crossing the y-axis. It crosses at positive 5 and it crosses at negative 5. So x-intercepts, there are none, but the y-intercepts, they're crossing at a negative 5 and a positive 5. And you should always write them as a point to remember that the x is 0 and the y in this case is negative 5 and positive 5. Good? Okay, they have another question. They want to know if there's any symmetry. We just spoke about symmetry, so let's take a look at this. We want to know, let's just keep order. Is there any x-axis symmetry? That's what I want to know right now. any x-axis symmetry. If I look at this point and it looks at the x-axis, is its reflection? Yes, it is. Its reflection is the same spot, right? Except in the negative end of the world. Okay, so x-axis symmetry. What about y-axis symmetry? What if I take this point and look at the y-axis? Yeah, I see it over here, don't I? So yes, it definitely has y-axis symmetry. Okay, now what happens if I take this point and look at the origin? Yep, I see it here too. I see the origin symmetry. This one has all three. This particular graph has x-axis symmetry, it has y-axis symmetry, and it's got origin symmetry. It's got all three symmetries. Pretty cool. Good? Okay, let's go for another one. All right, same questions. They want to know if this is a function first and foremost. So take a look. Here's an x value. Where's the y that goes with it? Good, up here. Is there any other place? Nope, I don't see it either. How about this one? Yeah, it's right there. How about over here? It's down here. So I don't see any second y value to go with any of these x. Okay, so it is a function. So let's look at the next question. The next question wants the domain, and the next question wants the range. So when we're graphing, the domain refers to the x's, and the range refers to the y's, doesn't it? So let's look at the x's. So according to this graph, the x's start here at negative pi. This doesn't keep going because it's a solid dot. So we're starting at negative pi, and as I move along this graph, I get every x value up until positive pi. And again, it's a solid dot, so it doesn't keep going. So in this case, it looks like we're going from negative pi to positive pi on the x's. And because those dots are solid, those are brackets. With me? Okay, let's look at the range. So the y values. It looks like we're starting our graph down here at negative 1, aren't we? And it moves up, it keeps moving up, and looks like it ends at positive 1. Okay, so looks like our range goes from a negative 1 to a positive 1. And yes, it's solid, so we're going to have brackets there. Does that make sense? Okay, let's look at intercepts, because that was question number 2. Do we have any intercepts? And again, when they say intercepts, they're looking for x-intercepts and y-intercepts. So be aware of that. All right, so x-intercepts, do we have any? Yep, looks like we have at negative pi over 2 and positive pi over 2. How about y-intercepts? Yep, looks like it's at 1. So, in this case, I have a negative pi over 2, 0, and a positive pi over 2, 0. And on the y-intercepts, it looks like we have 0, 1. Good? Okay, so now let's look at symmetry. And let's check out x-axis symmetry first. X-axis, so that means I pick a point here. It looks at the x-axis as a mirror. Do you see its reflection? Nope, not seeing any x-axis. All right, so let's look at this point, and the y-axis is now the mirror. Do we see its reflection? Yep, sure do. It's right there. So there is y-axis symmetry, right? And now origin symmetry. If I look at its reflection, I really don't see a reflection here because it's got to be right across from it, and I'm not seeing it. So in this case, all I'm seeing is y-axis symmetry. With me? Okay. Got another one. All right, so you guys take a look at this. You tell me if it's a function. Yeah, I heard no. I'm agreeing it's a no because I'm seeing this x has this y value and this y value. It's got 2 y values. Can't happen if that's going to be a function. Good. And it wants to know the domain, and it wants to know the range again, doesn't it? Okay, so let's look at the domain. Let's look at the range. So, domain. That's our x's. Good. It looks like these keep going out, don't they? Keeps going out. So this looks like it starts at negative infinity and ends at this number. What's that number? Good. 2. I saw that. So negative infinity to 2. Let's look at the range. Since this part keeps going down and this part keeps going up, what do you think the range is going to be? Yep, I heard you. That range is going to be negative infinity to positive infinity, isn't it? I agree. Let's look. Intercepts, do we have any? So we are going to look for any x-intercepts and any y-intercepts. So, do you see any x-intercepts? Yep, I do too, right here at that 2. And how about y-intercepts? Well, they look like they're crossing here. And I think the graph is a little off. I think it's supposed to be at -1 and +1 for the y's. So we saw 2, 0, and looks like we saw excuse me, I wrote that backwards, didn't I? See, this is why I need you guys do it with me. Looks like it was a +1 and a -1. Cool? And last but not least, that's right, symmetry. So, you guys take a look at this for a moment. See if we have any x-axis symmetry, y-axis symmetry, origin symmetry. What do you say? I vote for x-axis symmetry too, because when the x-axis is the mirror, this part above mirrors this part below. So I'd say that this has x-axis symmetry. And that's all I am seeing for symmetry. Good? Good. Okay, let's take a look at this one. Same questions. So they want to know if this is a function or not. Now, understand something. The function, or this graph, looks like it's hitting the y-axis, but it's not. It's actually just kind of skimming along right here, getting really, really close, but not touching it. Their drawing is not very clear. And so I need you to be aware that this graph is not touching that y-axis, and this is an open circle here. So would this be a function? Yes, it will definitely be a function because I see every x has exactly one y value. Here it's getting close, but it's not touching the y-axis. It's getting closer and closer to it, but it's not touching it. So this happens to be a function, okay? All right, they want the domain and they want the range. So let's go for domain, and then let's talk about the range. Okay. So the domain, those are the x's. And it looks like 0 for the x's, right? Because it's here, it's almost at the 0 for the x's. And it looks like it ends at, yeah, it looks like it ends at 5, doesn't it? Right? Okay, so I'm looking at 0 to 5. But am I going to put a bracket on the 0? No, because the graph isn't touching that y-axis where the 0 is at for the x. And am I going to put a bracket on the 5? No, because I have an open circle here. So in this particular case, your domain is from 0 to 5, but both of them have parentheses around them. Okay? Let's look at your range. Yeah, definitely at negative infinity, and ends here at 2. You going to put a bracket on that 2? Nope, a parenthesis again, because I'm seeing an open circle. So negative infinity to 2 with a parenthesis, because there's an open circle there. Okay, let's look for any intercepts, because that was also on our list. So I see an x-intercept right there. That's at 1, isn't it? Do you see a y-intercept? Yeah, neither do I, because remember, this graph is getting close to the y-axis, but it's not touching it. So in this case, I only have a y-intercept. Pardon me. Let's try that again. In this case, I only have an x-intercept, and that's at 1, 0. Okay. Symmetry. Any symmetry whatsoever going on here. X-axis symmetry, y-axis symmetry, origin, not seeing any of it myself. In this case, we have none. And by the way, y-intercept, none. Good? Okay, let's look at another one. Same questions. Okay, you start answering them. Let's see if we agree. Yes, I agree. It definitely is a function. Got it. I need the domain and range. Okay, so the domain, I agree, is from negative infinity to positive infinity. Because this keeps going out. Those arrows tell me it keeps going out, and eventually it's going to be at negative infinity. And since this goes out, eventually we'll go to positive infinity for those x's. Correct? Okay, how about the range? Yeah, we're starting at negative infinity, and it looks like you're ending at 10. Good. And on that 10, we have a bracket, because that's a solid line going through that 10 on the y-axis. And let me erase my line so you can see that it is solid. Okay, intercepts is next on our list. Have any? Yes, I see an intercept here, and I see an intercept there for the x's. Now, what are these increments? 1, 2, 3, 4, 5 tick marks, right? And it goes to negative 25. Good. That means they're in increments of 5. So this looks like a negative 10, and that looks like a positive 10. Good. What about the y-intercept? 1, 2, 3, 4 tick marks, and yep, that looks like a 10 also, doesn't it? Okay. So for our intercept, it looks like we have negative 10, 0. We have positive 10, 0, and it looks like we have 0, 10. Agreed? Okay. Symmetry. Got any symmetry? Take a look. I'll erase all my drawings here, and you tell me if we have any symmetry. Good. I see it also. All I see is y-axis symmetry. I don't see any x-axis, and I don't see any origin symmetry. Cool? Good, because if you fold it on the x-axis, on the y-axis, it mirrors itself. Awesome. Loving it. Okay, one more for these questions. Want to make sure you guys are good. You tell me if it's a graph. I'll wait. Pardon me, a graph. Listen to me. You tell me if it's a function. I'll wait. And yes, this one is definitely a function also. Okay, what's the domain? And what's the range? I guess you want to see the graph again to identify the domain and range, don't you? Yeah, domain is negative infinity to positive infinity because these will keep going out, won't they? How about the range? Yeah, it looks like the range is starting at this point, and since the range is the y's, it starts at negative 1, and it looks like it goes to infinity. Okay, so domain is negative infinity to positive infinity, starting at negative 1, heading to infinity, and that's a solid circle, which is why I put a bracket on that in case you were wondering. Okay, intercepts is next on our list. Take a look at the graph. Do we have any intercepts? I see this intercept and this intercept for x's at 2 and 4. And this one here. Is that one a 7? Let's see. 1, 2, 3. Ah, this must go in increments of 2, huh? 2, 4, 6, 8. So it looks like it's an 8 for the y. Okay. So, looks like our intercepts are 2, 0, and 4, 0 for the x's, and 0, 8 on the y. Good? Okay. Symmetry is next on our list. Do I have any symmetry? Yeah, not with respect to the x-axis, not with respect to the y-axis, not even with respect to the origin. This doesn't have any symmetry with respect to x-axis, y-axis, or origin, because those are the only three they want. So in this case, the answer is none. Later, we'll get into other symmetries that are not x-axis, y-axis, or origin. But for now, that's all we're dealing with. Good? Okay. Let's scoot on. Let's take a look at this. They've given me this function, and they'd like me to answer these 6 questions. So, first they want to know if this point, -1, 2, is actually on that graph. What do you think you're going to do to figure it out? Yeah, we're going to have to plug it in, aren't we? So let me get the function written down over here. 4x squared minus x minus 3. And the first question was -1, 2, right? They want to know if -1, 2 is on the graph of that. So, looks like we are going to have to do some plugging in. The -1 is x, the 2 is y. So we have 2 equals, right? Okay, you do your work. I'm going to do my work. And it looks like it does work. So, be careful which option you choose here. We know it works, so we know the answer is yes, but which yes is it? What did we substitute? Did we substitute x for 2 or x for -1? Yep, x was -1, so it's B. Okay, now let's look at the next question. If x equals 2, what's f of x? So what are you going to do? Yep, you're going to plug it on in. So this is letter A, this is letter B. If x equals 2, so you're going to plug it in, aren't you? All right, well, you do the work. See if we agree. Are we agreeing yet? I got 11. And they want to know the point. Remember, the point is x and y. Good? Okay. Well, I saw part C there. Let's see what they want. If f of x is -3, so is x -3? No, because it's over here. It's not in place of the x here. So -3 is equal to, good, y. And they want to know what x is. All right, so we have -3 equaling. Just want to make sure that was a -3. Equaling this function. So, how are we going to solve this? Yep, this square means you're going to have to factor, which means you need it equal to 0. So I'm adding 3 to both sides. Well, that makes that problem a whole lot simpler to deal with. And remember, if you're factoring, the first step of factoring is to take out anything in common. And then I get to set each one of these factors equal to 0 to solve. Okay, it also wanted the points. Well, one of my points is 0 for x and -3 on the y. My other point is 1/4 for the x and -3 for the y. Because this y, or this -3, was a y value, remember? Cool? Okay, we have a part D floating around here also. Let's see what they want for part D. What is the domain of f? That's part D. What is the domain of f? So remember when they talk about the domain, we have red flags, don't we? We got 2 of them. We have a denominator and we have a square root. So question, does this function have a denominator? Nope, so you're not kicking anybody out. Does this function have a square root? Nope, so you're not kicking anybody out. So in this particular case, your domain is negative infinity to positive infinity. Cool? Okay. Also, by the way, if you look at the graph of this, that's a parabola, isn't it? That's a parabola going up. Some of you recognize it. And even that shows me my domain would be from negative infinity to positive infinity. Good? Okay, let's look at E, because there was a part E. They want any x-intercepts. Okay, so how do we find x-intercepts again? Yeah, you have to let y equal 0. So to find x-intercepts, let y equal 0, which means I am going to get this particular function, or equation, I should say, and it looks like we're going to have to factor again, right? Okay, so you do your factoring, I'm going to do my factoring, and hopefully we end up in the same place. This is what mine factors to. Hopefully you got the same thing. And let's see. Set each one equal to 0, right? So when you set them equal to 0, x is equal to a negative 3/4, and x is equal to a positive 1. Excellent. So I have two x-intercepts in this case. Negative 3/4, comma 0, and 1, comma 0. Awesome. Okay, they had a part F, and part F wanted the y-intercept. Remember how to find the y-intercept? That's right. We let x equal 0. And this one is a lot nicer to let x equal 0, because you're plugging in 0 in for x, which is going to make our lives so much simpler, which means we just get negative 3. So my point is 0, negative 3 on that y-intercept. Good? Okay. One more question. It's a graph. And this graph is actually a lot simpler than it looks. Let's look at part A. Part A would like us to figure out this. F plus g of f. Now, you're like, how am I going to do that with a graph? Remember, f plus g of f can be written as f of 4 plus g of 4. What does the 4 represent? That's your x. F of 4? Yeah, that's a y. G of 4? That's also a y. The f of x function is the red line. The g function is the blue line. So look it up. When on f of x, the red line, when the x is 4, here it is, when the x is 4, it looks like the y value is negative 1. And on the g function, when x is 4, the blue shows me y, in this case, is also a negative 1. So we end up with negative 2 here. With me? All right, well, let's try another one. Okay, because some of you are like, kinda. All right, well, let's try another one. Let's do f minus g of 8, which means I can do f of 8 minus g of 8. So again, f of 8. 8 is my x. And this is a y for f, and I'm trying to find the y for the g. So look at the red line. When x is 8, the red line says when x is 8, y is negative 5. And according to the blue graph, when x is 8, y is negative 1. So it looks like I have negative 5 plus 1, which would be negative 4. Does that make sense? Loving it. Cool. Okay. Oh, okay. I hear you guys. You're like, do another one. All right, hold on. I need more paper. So how about we do F times G of 6. So remember, in this case, the 6 represents x, doesn't it? So that means I want to do f of 6 times g of 6. This is the y value for the x. This is the y value for the g. So let's go take a look. So here's my 6, right? According to the f function, the y is -3. According to the g function, which is blue, your y is -5. So it looks like I have -3 times -5, which is, yep, +15. Cool? Okay, hopefully these helped and made some sense. You all have fun with this, and I'll catch you on the flip side.